Good evening, everyone, and welcome to Monarch Migration, brought to you by Crawfordsville District Public Library and presented to you by Stephanie Morissette, that is your host this evening. I'd like to thank you for coming, and I'd like to make a couple of announcements before we get started. We will, as usual, be having a couple of book giveaways at the end of tonight's program. The first book is titled Four Wings and a Prayer Caught in the Mystery of the Monarch Butterfly by Sue Halpern. She is a nature writer, and so she takes us on an adventure through the mysterious world of the monarch butterfly from both a writer's perspective as well as a naturalist's perspective. Additionally, we have another book by one of my favorite authors. It's called Flight Behavior, and it's actually a work of historical fiction by Barbara Kingsolver, and it revolves around the monarch butterfly as well. Additionally, I would like to say that I'm sure I can anticipate a lot of my audience members, patrons are familiar with the monarch butterfly and its life cycle. Since we've been young in kindergarten, first grade, second grade, I think we can all safely say we've studied the monarch's life cycle at some point, however briefly. With that said, we are going to have a review of probably most of that information tonight, so it'll be a bit of a refresher course. And perhaps, if I'm lucky, we'll have a little bit of fun and throw in some information that you might not have known before. So without further ado, we will go ahead and get started on our monarch migration. So when I was growing up, I really wasn't as much into the sports as it seemed that the other kids were my age. In fact, I spent more time chasing butterflies than I think I did anything else. That and studying trees. So sports wasn't for me, but butterflies were. A story I would like to share from when I was about 15 years old. And let's just kind of focus on this image here. I went for a walk through the woods on the farm in which I grew up on. And it was probably maybe mid-October. Most of the leaves were already fallen from the trees. But as I walked, I noticed how beautiful the sun was, how it felt on my face, and I noticed some leaves on the trees just sort of wavering in the wind, fluttering. And as I watched and just looked at the beauty of the trees around me, I noticed that I was seeing several monarchs. In fact, more monarchs than I'd ever seen floating near each other ever. And then it dawned on me, all of a sudden, several realizations happened. One, there was no breeze that were blowing the leaves that I thought I was seeing, but instead there were monarch butterflies, hundreds and hundreds, possibly thousands of monarch butterflies dripping from the branches of the trees in my woods. And in that moment, I was so amazed at such a very small creature could have such an impact on not only the environment and where it was stopping over along its migration, but the impact it had on me the rest of my life. And so the image that you see here, all those little orange spots that could potentially be fall leaves, brown, gold, and orange, were all monarchs. And I had the privilege to witness that experience, and I'm glad to share that with you tonight. And with that excitement of that memory, I hope that we can find excitement in some of these new things we'll learn about this evening. So how did the word butterfly come about? There's no direct evidence to lead to one particular word, and so it's kind of a word mash. From the research I've done, it seems to be sort of a mash of a couple of different words with Old English roots. And the myth or the story surrounding the word butterfly comes from, I guess you could say, a rumor that went around about witches that had the ability to fly and maneuver around in erratic directions. And it was thought that these witches would steal butter and cream from the peasants. And this could perhaps be how a butterfly came to get its name, if we think specifically of both the yellow and white sulfur butterflies that we see. The most common butterflies that we do see are typically a yellow or a white color. So mash the words together, perhaps we get butterfly. But what about the monarch? How did it get its name? Well, it was actually named after King William III of England, who reigned as a monarch from 1650 to 1702. And so it was named for him as a symbol of its royal beauty, and also for the fact that King William's secondary title was the Prince of Orange. So no doubt it is definitely a royal butterfly. And finally, in 1758, Carl Linnaeus, the father of the scientific classification system as we know it, finally named the monarch butterfly as its own species. The scientific nomenclature, or the actual scientific name of the monarch, is known as Danaus. So the Danaus species, or the three different type of monarchs that we have, fall into this scientific nomenclature. So the three types of monarchs they have a range that is more widespread than one would imagine. So the different kinds of monarchs not only can live in central Mexico and North America, which is where the North American monarch is. There's also a South American monarch, and we also have a Jamaican monarch. And then other areas around our country where one would thought a North American monarch could be, is actually there, even in Australia. Something else interesting, monarch butterflies have even been bred on NASA's International Space Station. And if you look at the lower image there to the right, you can see that the chrysalis of those monarchs appear to be hanging to the side instead of from the top of its enclosure. And this would be an interesting formation since the monarch is not responding to gravity when they are preparing their chrysalis. Interesting information there. Down at the bottom, I've listed a link for NASA if you wanted to go and study more on this butterfly mission. That information is at the bottom of the screen. The three species of Danaus monarchs that I spoke of, the first one being Danaus plexippus, or the North American monarch. The image is on the upper left-hand side, is the North American monarch. The monarch to the right, upper image, is Danaus arapus, that's the South American monarch. If we look at both the North American monarch and the South American monarch as we have them here side by side, we notice that the lower edges of all the wings, the black and the white for the North American, if you look to the South American image, the white spots are more orange and a deeper tones of orange than on the North American. And then finally we have Danaus cleophile, or the Jamaican monarch, and we can see that pretty image in the lower butterfly. Again, in early school, we learned about the different parts of an insect having a head with compound eyes, or eyes that have multiple lenses in them, a thorax, or a central part, and then an abdomen. Butterflies, as we know, they actually have two upper and two lower wings, or two fore wings and two hind wings. And as a mature insect, or as a butterfly, they have 6 true legs, but while as a caterpillar have five false pairs of legs, also known as prolegs. Pro meaning before, so before legs, false legs. And these prolegs actually have little gripping hooks on them and are, if you can believe it or not, hydraulically powered. So as a little side note here, I'd like to say that we take a lot of technological and mechanical inspiration from nature, and it's actually has a word of its own called biomimicry. And so by studying monarch caterpillars and the way in which their prolegs are hydraulically powered, we can learn new ways to design our modern technology. Butterflies also have a proboscis, which is a curling tube-like structure that they use for sipping nectar. If you look at the upper two right-hand images, you can see those are very close-up images, microscopic images of a butterfly's proboscis. In the upper image, if you look, you can actually see a vertical line running down the center of the proboscis. This is actually 2 separate pieces of one tube-like structure of the proboscis. So when the butterfly unrolls its proboscis to sip nectar, it actually is unrolling one whole tube that is two working together as one. Very interesting. So these little hair-like structures can grasp onto the nectar and literally roll it up its mouth. Butterflies have taste receptors on the tips of their feet. That helps them know if they're on the right plant or they're looking for a different one. Both as a caterpillar and a butterfly, monarchs have what are called spiracles or breathing pores that are in their skin or their thorax or their abdomen. Looking to the lower right-hand image, you can see there are red arrows pointing down to dark black circles. Those would be spiracles on the back of a caterpillar. And then finally, as far as body parts for the butterfly, they do have antennae, and these antennae have multiple things that they do, including a sense of touch, a sense of smell, and then these antennae also help with their directional orientation to what we call its sun compass. So the antennae allow it to orient itself into the direction of the sunlight and therefore help its way along its migratory path. We'll get into a little more detail about the changing of the seasons and the different compasses, if you will, that impact the monarch's migration. Butterfly wings are exceptionally complex. They are composed of layer upon layer of scales, which are flattened hair-like dust particles that cover the wings. And they give the butterflies those multifaceted patterns or almost the iridescent sheen on the wings. The scales are lamellar or blade-like. Looking at the two top images of the color plates of the scales of the monarch butterfly wings, you can see they are tiny. They are very tiny and very blade-like, so lamellar. These colored pigments are actually what are called a structural coloration because the colored pigments are actually a combination of reflection and refraction of the colors off of those scales. And so it makes for a highly variable butterfly wing coloration. Not only this, but even further so, the scales help insulate the butterfly. And you wouldn't think so, but the scales are so fine and so dust-like that a butterfly can actually still fly without scales on its wings, without a large majority of scales on its wings. So they just provide a little bit of an insulation and a buffer. They additionally help thermoregulate the butterfly's body temperature. And they help with gliding and flying, giving them a little more substance, if you will, sustenance to their wings. They can act as camouflage from predators, and they can also warn predators not to eat them. And we'll talk about this here in a few minutes as well. But one thing that's really important that I wanted to discuss, well, it's all important to me, but specifically the pheromone production in the male monarch butterflies. There are black dots on the back of male butterfly hind wings, and we'll get a chance to view those here in a minute. But those black dots are actually scales, black scales that have a chemical in it that acts as an attractant to female monarch butterflies. So as you can tell, butterfly wings and the scales on their wings have a great deal more to do with the butterfly than just its coloration. If you look at the lower four images, those are just closer and closer up images of the structural nature of the color of each individual scale. I remember when we studied monarchs in the first grade and we learned about their primary food source, the milkweed. We studied mostly the common milkweed, which is the monarch caterpillar's primary food source. And milkweed just really will grow almost anywhere, disturbed areas, open fields, meadows, roadsides, and even in our urban gardens, which we as butterfly lovers and pollinator protectors want to encourage people to have more urban gardens for our monarchs. Female monarchs can sense the milkweed because there's something inside those leaves called flavanol glycosides. It's a type of sugar in the leaves that the monarch butterflies are attracted to, specifically for the flavanol glycosides they contain in those leaves. And as we know, the caterpillars, when they ingest those leaves, that milky sap that they ingest, it makes them taste bad to their predators later on. And we'll delve into that too. But the female monarch can actually, she can actually smell the host plant, the milkweed, and then she can taste it with her receptors on her feet. She can smell it with her antenna. And once she realizes that she is on the milkweed plant, this allows her to lay her eggs. So she's like, figured out this is the right place, this is the right time, and then she lays her eggs on the milkweed host plant. We have more than just common milkweed that's native to our area. Honestly, that's something new that I learned. I had only been familiar with 3 different types of milkweed in our area, but there are more than that. There are 14. And we are in the northeast native milkweed zone, if you will. And as far as the planting zone, if you wanted to put in pollinator gardens, our USA hardiness zone is 5B for our area. So by studying which milkweed plants or other pollinator plants would be beneficial to monarchs, we can help them again. And we're going to talk about how each and every one of us can help those monarchs here. The 3 most common milkweed that I alluded to that I'm familiar with is, well, we know the common milkweed, but also the butterfly milkweed, which has a really gorgeous orange color to it, almost the same color orange as the monarch itself. And then swamp milkweed is another one that I've been familiar with. But as I mentioned, there are 14 milkweed species that grow in Indiana, and here is the listing for those species. Now, in addition to not only listing them, for example, the first one, aquatic milkweed, that will be the first upper left-hand image, followed by the butterfly milkweed next to it, and so on and so forth. So as you can see, they do look very similar, most of the monarchs, or excuse me, not monarchs, milkweeds. Some color variation and a little bit of structural variation in the plant itself, but pretty much tell it's a milkweed. I've always wondered how it is that butterflies do mate. Um, it's just not something that's something that I didn't really learn about in school, and I wanted to know more. So what happens is the females are attracted to those male monarchs. We alluded to the little black dots that the males have, those black scales on their hind wings. So when the females become aware that there's a male in their area and they do decide to mate, they will clasp onto one another end to end on their abdomens. And this process can actually take quite a while. It's been documented up to 16 hours that monarchs can remain in this position. The first, second, and third generations of monarch butterflies, specifically the males, are reproductively mature within 1 to 2 days after emerging from their chrysalis, whereas female monarchs are mature within 3 to 5 days after hatching. And then finally, that 4th generation of monarch, the monarch generation that actually makes the entire migration to Mexico, these monarchs are not reproductively mature until after their overwintering migration, and then their return to the southern United States. It's so exciting. I can't wait to explain this all a little more in detail. If we wanted to find other ways to identify male and female monarchs, this image here shows a female monarch on the left image and then the male monarch on the right to show the difference in the structural anatomy of the butterflies. So the females have a little bit of a divot there, and the males have claspers, which allow it to clasp with the female. So once the monarchs mate and the female finds the appropriate host plant of milkweed that it wants to use, and it's stimulated to lay its eggs, those eggs can take 5 to 10 days before they hatch. And then the tiny little larvae or the caterpillars or in those stages up to 18 days. So anywhere from 11 to 18 days. The pupa or the chrysalis phase, if you will, when they're in the beautiful, just glorious green and gold chrysalis, uh, 8 to 14 days. And adult lives of butterflies typically are 2 to 6 weeks, depending on the first 3 generations, whereas the 4th generation can live up to almost 9 months. We're going to talk about how that's possible. Here's just a little bit of a pie chart graphic to give a quick indication of the majority or the portion of their lifetime they spent in each stage. And this, of course, is weather dependent. And those little guys, they need their scales on their wings to help insulate them a little bit more and thermoregulate. So basically, the warmer the summers, probably the faster growing butterflies will have. And then the cooler, earlier falls, less butterflies. So those little caterpillars, they go and they molt as they grow. And as they do shed their skin, they eat that skin. That sounds really gross. Why would a caterpillar eat its skin? Well, in nature, uh, as little waste as possible is kind of like the motto. So the caterpillars will ingest or eat their own skin when they shed because it helps them get a little bit of more protein back in their system because it does take a lot of energy to molt. And so if they ingest their outer skin, they can get that little extra nutrient boost that they need. And between each of these molts is a stage called the instar. So that's where it's actively eating and growing before it does its shed. And there are a total of 5 of these instars from egg to butterfly, at which time it will enter the chrysalis stage, and 10 to 14 days later, we should have our mature monarch butterfly emerging from its chrysalis. I want to emphasize chrysalis, not cocoon. Lots of people think that that's an interchangeable or synonymous word. That is not so. Chrysalis are for butterflies, cocoons are for moths. And cocoons are that soft, fuzzy, sort of looking um, structure that the moths develop in, whereas the chrysalis is a shiny, bright, uh, it's easier to see because it's more colorful than the brown cocoons of moths. So from caterpillar to chrysalis, here we have our monarch who's going into pupation, shedding its final skin and beginning to form that chrysalis. So when it hangs upside down, at least on Earth, they hang upside down and form a J shape, which is the result of gravity. So the little tiny silk button up there on the image of the J-shaped caterpillar is how it kind of plants itself and then it can hang there. And then the skin begins to split, and as it splits, the chrysalis forms around it, and that little bit of extra caterpillar skin from the molt crunches up there as the chrysalis begins to dry. The little black stem that results is what's left after the caterpillar sheds its final skin. And here we just see some more live images, or excuse me, closer up images of the caterpillar going into the J shape. How many eggs do they lay? That's a really good question. You would think I would have that information in here. I do not. Great question. So whoever has sent that in, I want to commend you and thank you for that. I don't have your answer, but I will put it in my next Monarch program. Congratulations, you've stumped me. But definitely more than one. And I would be as bold as to say probably dozens. However, without having that scientific research and documentation with that information of how many eggs a monarch can lay, I don't have an answer for you, but I do appreciate your question and thank you. Over on the very far right image, we see the chrysalis once it's completely formed, it's solidified, it's beautiful green. We can see the butterfly's wings forming on the inside and the gorgeous gold dots. It's such a decorative chrysalis for a royal butterfly. Another interesting thing we can do to find out if we have boy or girl monarchs, we can even do this while they are inside the chrysalis. This is an interesting fact that I learned for this program. I did not know there was a way to tell until after they'd come out of their chrysalis. On the left image, here we have a female, and where the word is pointing to a short vertical line, this is a female monarch in the chrysalis. In the image to the right, the male only has a slight dot instead of a vertical line. And upon hatching, proven to be male versus female monarchs. And we'll look at the more telltale sign here in a minute. Here we just have the chrysalis. It's dried out, it's turned clear, it splits open, the butterfly begins to emerge. And if you notice this, the very center image of the butterfly, the wings are kind of crumpled and the abdomen looks really big and juicy. Once they emerge from that chrysalis, they will pump their wings full of the fluid that's in their large abdomen so that they get that slender appearance and the wings become full. And once the wings are fully dried, that's when you have your first flight. All right, these are the easy ways to tell the boys from the girls. In the image to the left here, we have a male monarch butterfly, and you see those green circles are highlighting those black scales or those round black dots on the hind wings. This is a male monarch. These two round dots are the areas that exude the pheromones or the chemicals that attract the female monarchs. You can also see in that image, if you look to the lower left of the left image, that the round circles also appear on the underside of the male's wing. Next to it, the female monarch, you notice that she's lacking those black dots. That's one distinguishing way. And let's see what else here. The lines, the actual black lines on the female monarch are also much whiter. Let's see. Okay, quickly here. I have an answer. It appears Morgan Shanks has answered our question on how many eggs can a monarch lay? 300 to 500 has been the Google search number that has been found. So I want to appreciate that quick reference information there. So it's definitely more than one, that's for sure. Thanks, Morgan. We appreciate your input there. And that's what we're here for, is to all help educate one another. So let's look at our other image here on the right-hand side, the thinner veins on the male, but it does have the black spots. And then the lower image of the female, the wider black bars or banding and no black dots. Monarchs have a superpower. They have predator protection. And I alluded to that early on when I mentioned that the female monarch butterflies are attracted to the host plant milkweed because of the flavanol glycosides that are in the leaves itself. So when the caterpillars eat that and it works up through their body through something called biomagnification, so it builds up and gets more and more in the system. And then when that caterpillar emerges as a butterfly, it still has those toxins from the milkweed in it, and they're then called cardiac glycosides. And this makes the monarch just taste terribly bitter to predators. And therefore, some predators begin to associate the color orange with the sign of danger, that monarchs taste bad. So some birds will avoid monarchs because they have a nasty taste. And here are just a few of the different predators of the monarch butterfly. Predator protection goes beyond just the color orange for the monarch, and it extends over into another butterfly that actually mimics it, and it's called the Viceroy butterfly. If we look at first glance, they do look very similar. The one on the right looks a little beat up, and the one on the left looks really fresh. If we look to the image on the right, there is a black bar that goes all the way across the lower hind wings on each side. But our monarch, male or female, will not have these black lines across the bottom of the hind wings. So if we're able to get this close to these butterflies, we would be able to tell the one that was the real monarch and the one that was mimicking the monarch, the Viceroy butterfly. So because of this color association of orange and predators usually trying to avoid the bad taste of monarchs, the Viceroy benefits from that by mimicking the color pattern of the monarch butterfly and kind of increases its chance of survival. Here we just have a couple more images of Viceroy mimicking the monarch. subtle differences. Monarch flyways, or the migrational paths of these butterflies, it's an outstanding feat of nature that has the world over fascinated that these little insects can make such a great journey. In the springtime, when the monarchs leave their overwintering grounds in Mexico and travel north, this happens usually maybe late February into maybe early March, again, weather dependent. And so those butterflies at that point, when they're beginning to migrate back to the southern United States, they do become sexually mature at that point. So that's generation number 4 that's starting over the trip back up to begin the first generation. So these monarchs, they can travel 50 to 100 miles a day and up to 2 whole months migrating when they're on their fall migration. So September, October, again, weather depending. The 4th generation monarchs, the ones that are way up there in the northern United States, maybe even into just the southern tip of just the bottom part of Canada, these guys are going to make it all the way to Mexico, giving them the longest lifespan of all 4 generations. This can be up to 9 months. And the farthest ranging monarch butterfly that has been recorded as traveled is 265 miles in one single day, as recorded by the USDA Forest Service. And we will talk about how in the world do you know a monarch butterfly has traveled 265 miles in a single day? We're going to find out. But to continue a little further talking about that fall migration. So that fall migration is the 4th generation of monarchs in that single summer, in that single year. And this last generation of monarchs for the season, they can sense changing in the seasons, the changing in the sunlight, the changing of the temperatures. And this forces the monarch butterfly's body to go into what's called diapause, a temporary reproductive system shutdown. So because the temperatures are cooling, there's less daylight, the butterfly needs to conserve its energies for the migration. And so it just kind of closes up shop on a lot of different systems for a short while, turns that energy that it could have used for reproduction and uses that conserved energy for stored fats that it can use during migration. And it also, by having that extra stored fat in its body, helps it become a little more resilient to the colder temperatures that it will experience during its migration. Something special too that monarchs do that scientists believe help them navigate in conjunction with their, what we refer to as a sun compass, or they follow the direction of the sun, south. But they have another type of compass, or a magnetic compass, that uses UV light. And these little special UV light receptors are called cryptochromes, and they work in conjunction with the sun compass as a magnetic compass because of the photosensitive magnetic sensitivity of the lighting and how that affects all the butterflies' circadian rhythms. These 4th generation monarchs, from as far up as Canada, will travel up to 2,000 miles to the Oyamel Fir Forest in Sierra Chinqua Butterfly Sanctuary in the Sierra Madre Mountains of central Mexico. This is known as the Mountain of Butterflies. This specific forest type, a temperate coniferous forest, is only 2% forested in the Oyamel Fir Forest. It's the most endangered forest ecosystem that is in Mexico, and it is the place, like the winter hangout for all monarchs, the North American monarchs. So these 4th generation monarchs, they're still using that overwintering fat reserve that they've saved up, and they're going to use that when the temperatures start to rise again in February, March, so that they can become reproductively mature, travel back to the southern United States, and begin the first generation over of monarchs that live 2 to 6 weeks and continue the migration north. The 2nd generation, that continues north. 3rd generation, until finally we have our 4th generation that makes it all the way down in a single trip. Here's just a larger image of the one on the previous slide. The little red triangle and all the sea of mountains that are there, That little spot is the oil mill fir forest that the monarchs critically need. Here again, we just have another map to just kind of put in fewer words the different generations. So there are a total of 4 generations in 1 year. Some people, I think, mistakenly believe that it's the same monarch that makes the trip, and that's not true. So the first monarch, the second monarch would be the children, and then you would have the great-grandchildren, or the grandchildren, and then the great-grandchildren, and then so on and so forth until the 4th generation rolls right back around and starts generation 1 over again. So the first generation is typically around February and March. That second generation, those monarchs are still moving northward, April and June. The third generation into July and August. And then finally our 4th generation, September and October, are the ones that return all the way south. I've talked a few things about how we can help with monarchs, how we can do our part as citizen scientists. Let's first define what citizen science is. Citizen science can be defined as anyone of any age with or without formal scientific training to report research information on the monarch butterflies. Now, not only does citizen science work with the monarch butterfly, citizen science projects are all over the world and all over our country and pretty much any type of scientific interest that you have. But for us today, we're talking about monarch butterflies. As most of you may know now, the monarch butterfly is on the threatened species list. And this December, it is to be voted on as to whether it will go on the endangered species list. So lots at stake for the monarch this year, and how we can do our part as citizen scientists to help is we can create what are called Monarch Waystations, or simply stopovers. I used the word stopover when I discussed the memory of the monarchs that I had. Waystations are stopovers for monarch butterflies, or really any pollinator that you want to help on its journey. But Monarch Waystations and citizen science work together with monarchwatch.org. And what Monarch Watch does is they have a tagging process for monarch butterflies. Yes, you can tag monarch butterflies. You can put small stickers on their hind wing in a very specific location that's not detrimental or inhibitory to the flight of the butterfly. And each little sticker contains a number, and that number is recorded into a spreadsheet with the number and the date and the location of where it was tagged, and then those butterflies are gently released. There's a certain way to hold them so that you don't injure them, and even if you do knock a little dust off the scales, you're not going to injure the butterfly, so they can still fly with some scale loss. And then release them and let them go, and the scientific hope is that when or if those monarchs are recovered, they can look to the little sticker on the butterfly's wing and determine when it was tagged and where it was tagged, and therefore how far it migrated when it was found. So all that information from all these citizens, you, me, young, old, and in between, of all levels of scientific abilities, can do this and help scientists learn more about our monarch so that we can help in the conservation efforts to see it come hopefully off the list of threatened species. If you decide to build your own monarch waystation through monarchwatch.org, if you pledge to make a certain habitat with milkweeds and nectar plants for pollinators, you will get a certificate of appreciation as well as a wonderful, nice metal sign to display in your pollinator garden as a monarch waystation. So there are benefits not only to helping the butterflies, but gaining the knowledge that we need to help them, and then that just furthers our respect and understanding of this magnificent royal butterfly. This map here is registered monarch waystations throughout the United States as late as of July of this year. These can be at schools, these can be in your backyards, these can be urban gardens that different community groups take care of. Anyone can literally make a monarch waystation. And as I mentioned, right now, the monarch butterfly is on the threatened list for potential movement to the endangered species list. So right now, we're still really hoping that the monarch butterfly can pull out of the being threatened, and if we can get those numbers significantly up. But the monarch butterfly became threatened. It went on the list in 2014. And this December, the U.S. Fish and Wildlife Service will vote on the status of the monarch, whether it will stay threatened or whether it will go on into being in the endangered category. So we really need to help this monarch as much as we can. Other organizations that are involved with monarch preservation or conservation in some way include the World Wildlife Federation, the Nature Conservancy, and even the Environmental Defense Fund. There are some other websites and partnerships. These are some friendly e-resources, government resources, and nonprofit organizations. The Monarch Conservation Science Partnership, Journey North, Monarch Watch, which is the one that we've been discussing, and then always you can go to the USDA and the Natural Resources Conservation Service. I want to thank you all for coming. I know that was a relatively short program. However, like I said, many of us are familiar with the monarch butterfly, and I just hope that maybe there was one little bit of information that you found interesting that you did not know before. Let's see here. I want to thank Sherry Macy for her comment on the program. It's greatly appreciated when we hear good feedback from any or all of you. We have some other comments. It looks like Susan O'Neill has released, it looks over 200 monarchs this year. Is that correct? Incredible. Well, you have your very own Monarch Waystation and didn't even know it yet, and just incredible. I would encourage you, Susan, then to reach out to monarchwatch.org and see about getting yourself a pollinator waystation going for the monarchs. Let's see, more milkweed. Jessica says we need to grow more milkweed. We do. And I'm glad to read this comment because, Jessica, we do need more milkweed. Just growing up, I'm in my mid-40s, and growing up young, there were monarchs and milkweed absolutely everywhere. But since even in this time period, a lot of fence rows and country areas have been removed, and a lot of herbicides and pesticides have been used, and so we've lost a lot of that host plant, the milkweed for the monarchs. So yes, we all do need to grow more milkweed and more plants for our pollinators in general. I don't know much about eastern black swallowtails, but perhaps we might have a program on one of those if we have other butterfly experts. So for all you lepidopterists out there or butterfly scientists, I want to thank you again for attending tonight's program on the monarch butterfly, Danaus plexippus. And okay. And well, I'm sorry, one moment, please. I got to get something cleared up real quick. What was that? I'm sorry.
Just have them send an email to Ref
okay.
for the prize drawing.
Okay, all right,
yeah,
sounds
so
good.
Just email us tonight.
Okay, yeah, perfect. Thank you. All right, I just had an update on how we're going to do the selection on the prizes this time. If you would please, if you're an attendee here, email ref, that's REF, at CDPL for Crawfordsville District Public Library, .lib.in.us. Again, that's REF at cdpl.lib.in.us, and we will do the prize selections this way. So there's a big factor for you to get off right now and hop on and send an email to us, and we'll be happy to get your prizes to you as soon as possible. Again, I thank you, and I look forward to your book reviews on Four Wings and a Prayer and Flight Behavior. Thanks again.